Well, going back to that COP26 video, just from what I remember, like the sea level rise issue, how vulnerable the ice is, and just like
Yeah,
once it starts going, it's gonna go fast.
it's going to go fast, and like I did that water expulsion mechanism of a video with the Antarctic ice, which I found to be an intriguing uh, uh, explanation that those researchers came up with. That you basically have the water infiltrating even under the bedrock, which then helps loosen and melt it because it's warmer and all this other stuff. And then it helps you know basically remove the ice. And then someone left a comment on my site, go, could this mechanism be applied to Greenland? And I replied, I don't see why not, in the appropriate locations. And I said, I think that was the point of their research, was to apply what their potential explanation is to other locations that as applicable. But I saw something interesting, and I'm going to be doing a video on this, is that where everyone's focusing on the Greenland's ice melting, but what about the ice that doesn't melt, but somehow is transported away from Greenland? What happens to that ice? And sometimes some of that ice gets caught up in mesoscale eddies, so it ends up in not so much the North Atlantic, but at the northern end of, say, the North Atlantic gyre. So you're having these ice basically bringing fresh water when it will eventually melt. But basically what they're saying is that instead of all the fresh water being concentrated right around Greenland, by having a mechanism bring icebergs away from that, it would be actually spreading the effect and the distribution of the freshwater input. So that's going to kind of be an interesting little video, I think.
So this is the freshening atlantification issue as well. Like this is
it's related to that, but the paper is looking more at other mechanisms to distribute the ice further and like away from the North Atlantic to mid-latitude Atlantic.
interesting.
And then what happens to that? So and then someone posted comment, goes, Jim, you should check this out, or asked me my opinion of it. I said, well, send me some articles, I'll look it over. And that with all the ice melting that's going on in Greenland and Antarctica, that apparently, the person saying, creating mass, you don't create mass, you just simply redistribute it. But basically it's like, so you had all this ice here, right, up at Greenland, and now you're moving it, you're spreading it this way. So you're spreading that mass around. Well, how is this spreading of the mass, redistribution of it from A to B? What is that doing to the Earth's rotation, the angular momentum? What's that doing to orbital mechanics and that sort of stuff? I don't see orbital mechanics changing much, but it's possible you could alter the angular momentum because you have different mass distribution. So that could affect things. How in terms of climate, I need to think about that. So I'm going to go check out some of these papers just to get my take on it. So I may or may not do videos on that upcoming, but we'll see.
It does sound interesting.
Now, here's an update on conditions in Alaska. Okay, today it's 32 below here.
Oh my God. Okay. Holy shit.
It was 30 below last week, and then it warmed up to like 5 below during the week, and it was like 5 below, and then last night I just watched the temperature kind of go boom, 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 boom. It went from 5 below to 32 below in like hours. And it's supposed to bounce back up tomorrow, what have you. But when you look at the sea surface temperature and the sea ice, okay, first of all, air temperature and sea surface temperature are cooler than average right now. And the sea ice has rapidly formed up in the Chukchi and the Beaufort Seas. such that the point that when you look at its distribution, it's kind of in the median, around the median level. So it's some of the thicker ice we've seen in years. It's not above the median, but it's certainly not at the low end. But when you look at the rest of the Arctic Ocean, sea ice is down. So what's going on that right off Alaska and through the Bering Strait, we just have a thickening of the sea ice, and we have all this cool temperature. I think there are several possible explanations. One is there were a bunch of storms a few months back, earlier this year, that really churned up the water in the Gulf of Alaska, the Bering Sea, through the Bering Strait into the Chukchi. Now, when I explained in my overturn mixing stratification video, it's like when you have the breakdown of the stratification, you get density current that can overturn and mix the water column. Well, you can also have mixing of the water column by good old physical action. Winds, you get a bunch of wind blowing on, it just stirs the shit up out of everything. So I think what happened was stirred up the colder water from deeper depths, you brought it to the surface, hence cools down the atmosphere. Also, when you look at the Pacific Decadal Oscillation, it's in the phase where the Northeast Pacific Ocean is cooler than usual. It's on the cool side of things. Coupled with the La Nina that's taking place leads to the condition that we're having cooler conditions up here in Alaska. And finally, the good old Arctic dipole.
Yeah, that's what I was thinking of.
That's set up such a way that we just have this tongue that slashes from northwest to southeast right across Alaska to Yukon into Nunavut. It's just this cold tongue just slicing across.
Interesting. But again, it's the perturbed system. Yeah.
So we just have this interesting thing going on.
And then there's the methane issue too. We talked about that the COP26 talked about, but at like the very end, yeah, the methane issue too is, obviously there.
And that's why I did that isostatic rebound. You melt the ice, the land rebounds, and let's methane loot, as though we don't need another mechanism.
Again, it's the borrowed time issue. Yeah, so this is where like the COP26 is an issue, because like what data are they using to make their political decisions? They don't really talk about it. They're underreporting. So God.
And when you look at the models and they extrapolate and you see a lot of them curving down, they are assuming that remediation mechanisms will be in place by then. They're assuming we'll be drawing down the CO2. They're assuming that we'll be off fossil fuel. They're assuming a whole bunch of shit, crazy things that are not valid.
Interesting. And that's how they're making their decisions on like a fantasy world. Oh God.
And that's how they basically say it's not so bad. If we cut off all fossil fuels now, we can keep it under 2. No, you can't, because of, wait for it, ocean heat content.
Yeah, and you talk about that. I mean,
and I keep, we keep bringing this up, but it's worth drilling this point home. 93% of all greenhouse gas emissions and heat energy produced in the last 50 years has gone into the oceans. That's CO2, that's heat energy, gone into the ocean. Look at what the 7% that stayed in the atmosphere, look at the havoc that 7% is doing.
Yeah, world of extreme.
What the hell do you think is going to happen when, let's say, even 1/4 of that latent heat energy makes its way into the atmosphere? All right. So if we're saying, well, 7% has caused the planet average to increase by, say, half a degree in its 50 years, what have you. What do you think? Another 25% there, that's what, almost another 4 times. That's an additional, let's say conservative, an additional contribution of 2 degrees C, in addition to all the positive feedback mechanisms that have kickstarted. We hit 4C very easily. And don't forget, the permafrost and the Amazon rainforest are now carbon sources. then no longer carbon sinks.